was getting tired of black background. We're going to try this green. It's like old school. Actually, this is like the chalkboard in our classroom. It'll be just like being in the classroom. Although I chose ugly colors to use. So it's going to be kind of gross. All right, let's do another surface area example. All right, so let's talk a little bit more about surface area. Before I do that, I'm hoping you're watching these videos in order. If you are, that last example, we had y equals x squared, and we rotated around the y-axis. That was the last problem. And the boundaries they gave were from 0, between 0 and square root of 2. I want to talk to you about if you would have rotated that around the x-axis. Okay, so let's say I went around the other axis. So the graph looked like this. We had y equals x squared. We only were interested in a portion of it. And if this time, if we were rotating around the x-axis, well, we're still going to do little cylinders, okay? Only this time my cylinders would go this way. I'd have a section of the curve, and then I would rotate that thing around. And so it would look like this. I would still have my little tupac, and I need the radius and the height. Only this time, the height of my cylinder, if you turn it on the side, is the arc length. It's the distance from this point to this point on my arc. And so that would be the square root of 1 plus. My function is in terms of y, so it would be the derivative of y, right? So far it's the same. But my radius this time, so that's height. The radius, though, is a vertical line, and vertical lines are y. And so I'd have 2 pi. So if that were the case, you'd have a problem because, first of all, your boundaries would be in terms of x's. And so you can't have x boundaries and plug them in for y, so that's a problem. And the other thing that would give you a problem is that over here, when you do the derivative of y, you get it in terms of x's. And when you square it, you get 4x squared. So you would end up with 2 pi y times the square root of 1 plus 4x squared. And you're mixing variables here, and that's yucky. So the nice thing about this is you're going to set it up like that. You're going to use your picture. That's going to help you figure out what your radius is and what your height is. So first thing is you kind of look at your boundaries too. If your boundaries are in terms of x's, that means you want your function in terms of x's. So even if they did not give you the function with y by itself, you need it. And then in this case, like if we had a vertical for our radius when we rotate around the x-axis, and that's y, instead of using the letter y, you have the definition of y. You have what it equals right there. So you would just substitute its value in its place. So now what we have is we're going to integrate from 0 to square root of 2. We got old 2pac. Instead of using the letter y, we're going to use its definition, which is x squared. Again, we got that from way up here in the top left corner. Oh, I got to pull it down. That's where we started. Y equals x squared. Those two are equal to each other, so you can use them interchangeably. And then I would have 1 plus 4x squared to the 1/2 power. And then you would do the problem from there. Okay, now this one, actually, it's a good thing they didn't give it to us because that actually is a problem for us right here. But I wanted to show you this to show you that it didn't matter what axis you rotated around. You don't have to change your equation. And you don't have to change your boundaries. But sometimes you might have to change what your radius is. So again, according to the picture, if you're going around the x-axis, your radius should be y. Sometimes you might use the letter y. Sometimes you might have to use its definition. So I wanted to bring that up. And I'm going to close this video here, and then I'm going to do a different one. So this will be example 2.